Open your book to page 413. This is lesson 14.3, and this is a substitution method. And so if you look at example 1, you have y equal to x plus 4, and you have a second equation, x plus 2y equal to 5. Again, when you're solving equations, make sure you do it side by side. Don't put underneath like in the book, because you're going to run into problem later on. Okay. Now, again, I mentioned earlier, right? When you have the equation looks similar, right? You have the x, y equal number, then you want to use elimination method. But when you have two equations that look different, right? So you have y equal x plus 4, and this one is x plus 2y equal to 5, right? So when you have two equations that are different, or when you have a variable equals something, right? So this is always kind of solved for y already. When you have this kind of situation, you want to use a substitution method, okay? And the way this is going to work is that you have y equal to something, right? And so whenever you see y, you're going to replace, right? Again, that's what substitution means. Substitution is making an exchange. They are same, they are equal. So since they are equal, they are interchangeable. So you can change this for that. Just like you can change a dollar bill for 4 quarters, right? Because they are same value, right? So you can make a change. Same thing over here, right? Think of it that you can change a dollar bill into quarters, right? Okay, so you're going to get x plus 2. Now y is equal to that, so you substitute. So you change the y into x plus 4. So again, y equal to x plus 4. So they are equal, so they are interchangeable. You can change them. So this is how you get rid of one of the variable, right? So now if we become regular solving, so you just go and get rid of the grouping symbol. So this times that would be plus 2x, multiply, you get plus a equal to 5. So let's combine the like terms. So you get 3x plus 8 equal to 5. Again, so now it's just regular solving that you learned earlier, right? So minus 8, minus 8. So you got 3x equal to, they're opposite signs, so you have to subtract the numbers, so you're going to get 3. And you follow the sign of this, it will be negative. And after that, to undo the 3, you have to divide by 3, right? Again, you always have to do opposite to undo, right? Divide by 3. So x equal to negative 1. Then after that, once I found x equal to negative 1, I can go back over here. You can use this one, but this is much easier because this will have y equal to whatever already, right? So let's go and use this one. Again, when you substitute, put in parentheses, right? So you got negative 1 plus 4. So again, they're opposite signs, so you have to subtract the number. So 4 minus 1 give you 3, and you follow the sign of that, so it will be positive. And so that's it for example 1. Yeah, let's go to example. So when you have this kind of situation, you can just use that, right? Now, when you go to example 2, on page 414, so you have x minus 2y equal to 11, and you have 3x plus 5y equal to negative 11. So with this kind of problem, okay, they look similar, so you can go ahead and use the elimination method. Okay. So you can do it. You can do either method. So to do this method, you have to plus 2y before you can substitute. Okay. So I'm going to use the new method. Okay. But normally you want to use the old method because, like I said, because two equations are similar. So you can just make the x opposite. So multiply this by negative 3. If you multiply this by negative 3, then it becomes minus 3x, and you can put on here to eliminate, right? But I'm going to show you how to use how to use a substitution method. So to use a substitution method, you need to have like y equal to whatever or x equal to whatever. So in this case, you need to go and plus 2y. So plus 2y. So you got x equal 2y plus 11. Okay, so you need to have this kind of situation. You have x equal to whatever or y equal to whatever in order to use the substitution method. So now let's go and substitute in here. So this becomes 3 times, again, x, it tells you what x equal to, right? Is 2y plus 11 plus 5y equal to negative 11. So to use substitution method, first you need to do is you have to isolate a variable. So you can substitute into here. Again, x equal to that, x equal to that. So they're interchangeable. So now you can go and work it out. So it'd be 6y plus 33 plus 5y equal to negative 11. So combine the like terms. I get 11y plus 33 equal to negative 11 minus 33. Right? Again, you have to undo that first, right? So I get 11y equal to, now they are same sign, so you have to add the number together. So you get 44 and it'll be negative. So divide by 11, divide by 11. So y equal to negative 4. So once I find y equal to negative 4, I can come back over here. You can use the other ones, but it's more complicated. This is the easiest one to use. So just substitute into here and then you're ready to solve already. So y equal to negative 4. So x equal to multiply out, you get negative 8 plus 11. Again, one step at a time. Okay, so x equal to, when you add, you get 3. So that's it. Okay. Now, I'm going to do the example 2 again. I'm going to using the elimination method so you can see the comparison. So example 2, page 414, you have x minus 2y equal to 11, 3x plus 5y equal to negative 11. So make sure you're familiar with both methods because you're going to need to use both of them, one time or the other, because sometimes one type is easier, one method is easier to use than the other. It all depends on the equation that you have. So this one I'm going to use elimination method. So I'm going to make the x opposite. So I'm going to times this by negative 3. So I get negative 3x plus 6y equal to negative 33. And I'm going to put this under here. So I get 3x plus 5y equal to negative 11. So when I add this cancel out, so I get 11y equal to 44 negative. Okay. Then I'm going to divide by 11, so y equal to negative 4. Then after that, now once you solve for y, then you can go back and use any of the equation. I'm going to use this one over here. Use x minus 2y equal to 11. So x minus 2 times negative 4 equal to 11. So x plus 8 equal to 11. Right? Work it out. So minus 8 minus 8. So x equal to 3. Okay. So you can see that you get the same thing, right? Okay. So make sure you be flexible with your techniques. Okay. So make sure you know both methods. Okay, let's go to example 3. Example 3, you have x over 2 plus y over 3 is equal to 2. You have x over 4 plus y over 2 equal to 2. Okay, so now you have fraction. So first thing you want to do with fraction is that you want to get rid of the fraction. So you want to multiply by common denominator. So this one, 2 and 3, the common denominator is 6. Okay? Now let's say if you don't know how to figure out the common denominator, then what you do is just go and put all the common denominator together like this. So let's pretend that you don't know how to find common denominator. And all you have to do is just go 2 and 3, go 2 and 3, and you go 2 and 3, right? So that this cancel out. Once you cancel out, you write it down right away, so it'd be 3x. This can cancel out, so it'd be plus 2y. And this one, you can multiply, 2 times 2 is 4, times 2 is 12. Okay, so that's how you do it. Okay. Now this one, you do the same thing. So this one, the common denominator is 4, right? So multiply by 4. Okay. But like I say, if you don't know how to get common denominator, just go and multiply by 4 and 2, that's fine. But if you know how to, or if the number is too complicated, then don't waste time looking for LCD, the common denominator. Just put all your denominator up here like this, 2, 3, 2, 3, 2, 3, and work it out. So this one is kind of easy, so we can do that, multiply by 4, right? So this cancel out. Now, as soon as you cancel, go and write it down. Don't cancel everything and try to go back, because you might lose track of what you have. So this cancel out. Again, give yourself enough room on the top so you can write all these things down. So it'd be plus 2y, and this one does not cancel, it'll be 8. Okay? So now this is what you have. So now it becomes the regular solving method, right? Now notice the y already, this is 2y, this is 2y, they are the same. So I'm going to make them opposite. So I can multiply by -1, or you can multiply by -3 to make the x opposite. So you have to decide which variable you want to make it opposite. I'm going to make the y opposite, so I'm going to multiply by -1. So I get -x minus 2y equal to -a. So now they're opposite, right? So I'm going to put this over here. So I get 3x plus 2y equal to 12. So it doesn't matter which one you want to make it opposite, but you got to decide. Make up your mind first. You want to make the x opposite or you want to make the y opposite? Okay, so this cancel out, so you get 2x equal to, now they're opposite signs, so you have to subtract the number and follow the sign of that. Then after you divide, so you get x equal to 2. Now once you find x equal to 2, you can go and use any one of this equation. Okay? So I'm going to use this one because this is easier to use. Okay, because it's lower, right? So you can use this too, but this is too messy, right? So you're going to have x plus 2y equal to a. So I'm using this equation. I'm writing it over here. Then I'm going to substitute. Then I'm going to minus the 2. So I get 2y equal to 6. Divide by 2, so y equal to 3. Okay, and that's it. Okay, let's go to example 4. So you got 6x minus 2y equal to 3. You got 3x minus y equal to y. So this kind of looks kind of weird, look kind of messed up. This is kind of reversed, this kind of flipped. Okay, so I'm going to rewrite this one so it's easier to to follow, because sometimes this can easy especially people with for those people are dyslexic, it's very difficult. So I'm going to flip this over, so you got y equal to 3x minus 1. So this type of problem you want to do substitution, right? So substitute this into here. So you got 6x minus 2 times, again it tells you what y is, right? Y is 3x minus 1 equal to 3. So again, when you have one variable equal to whatever, that's a good indication that you want to try the substitution method. Okay, so now let's go and work it out. So you multiply, you get minus 6x, multiply, you get plus 2 equal to 3, and this cancel out. So you're going to get 2 equal to 3. So this is contradiction, right? Cannot. So your answer would be inconsistent. Okay, so again, because this is false, so it'd be inconsistent. Okay, let's go to example 5. So on page 416, example 5, you got two equations. You got 3x minus 12y equal to 6, and you have x minus 4y equal to 2. So again, notice this equation is multiple of 3. So I'm going to divide by 3 to lower my equation. Okay, I'm going to divide this by 3 to lower my equation, easier to deal with, right? So you get x minus 4y equal to 2. So right away, you can see they're identical. So when you're identical, it's going to be dependent, right? But let's say if you don't see that. If you don't see that, I'm going to eliminate the x. So I'm going to multiply this by -1 to make the x opposite. So you get plus 4y equal to -2. And I'm going to put this under. So you got -x plus 4y equal to -2. So cancel, you get 0 equal to 0. So this is true, right? So in this case, this will be dependent, right? Okay, and so this is a dependent equation, right? So again, so if it's false, it's inconsistent. If it's true, it's dependent. Just like before, right?